Okay, this is another example, very similar to example 1. So we have, again, we want to find our f of t, which is going to be a piecewise function, and we want to definitely graph that. It's going to have a step function involved. So let's go ahead and we can definitely take out that 5, right, since the inverse Laplace is a linear operator. So I'm just going to go ahead and take out that 5 times the Laplace inverse of and I just took out a 5, so I don't need it there anymore. And we have, let me just erase that. We have e to the negative 2s, and I'm going to go ahead and write times 1 over s squared plus 16, because, I mean, that's what it really means. And then I'm going to go ahead and, well, I mean, this definitely looks like our theorem 1, right? This guy again. Let me get my white here. This guy, right, that is our e to the negative as in our book. So our a is definitely 2. And then this guy, right, that is definitely, right, a function of s. So I'm going to go ahead and rewrite this as, so same thing times, right? But we really know that this guy is 4 squared, and I'm rewriting that, rewriting my 16 as 4 squared because it looks very similar to one of our Laplace inverse transforms that that you've been working with. Okay, so what is, again, this guy, according to by our theorem, right? I think I did it in pink the last time. So by theorem 1, I can definitely say this is 5 times, well, 5 times, well, okay, some function f of t, which we haven't determined, but we definitely know it's going to be f of, and it's going to be a shift, right, a horizontal shift on the t-axis, so it's definitely going to be t minus a, in this case it's 2, and then we're going to multiply by our unit step function, which is going to be u of t minus 2, right? But we still have to multiply this guy by an f of t. So the question is, what is our f of t? And in the very first example, our f of t was the identity function, right? The nice linear function y equals x, which goes through the origin. So in order to determine what our f of t is, well, what do we have? What do we know? Well, we know, and let me, I don't know, use a different color here. We know this guy, right? That is our f of s. So we know that our f of s, right, is equal to, well, let's go ahead and write it as 4 squared. But my goal is to find f of t. So remember that this, our capital F of s, that's the same thing as the Laplace of our f of t, right? I mean, well, I guess I could have written that in green. But we want to find f of t. Well, if we want to find, well, let me actually go ahead and write this guy just to be consistent and not forget my expression there. Okay, so I want f of t. Well, so how do I undo the Laplace? Well, I can just take the inverse Laplace, and that's what I'm going to do. I'm going to take the Laplace inverse of both sides, right? That's an inverse. And go back to white, right? Because these are inverse operators, so I definitely get my f of t, which is the Laplace inverse of 1 over s squared plus 4 squared. And from, right, section 4.1, 4.2, you've been finding inverse transforms, or hopefully you've had practice with them. Well, this one definitely looks like our sine function, our sine kt. If you look at the table, this guy, right, is really k. Now, let me just get a different color here. Okay, let's use this pink. If this was a 4, right, this would be sine of 4t, but it's not a 4, but we can make it into a 4, right? We can definitely multiply, right? I multiply by a fourth, and then I multiply by 4, so I'm really multiplying by 1, which does not change the value. So I can definitely say this, oops, I can say this guy, right, this guy, according to our table, right, in section 4.1, that's definitely sine of 4t, right, or sine of kt. So, I mean, okay, so again, we have our a 1/4 here, so I just want to be careful with our notation here. So our f of t is equal to this guy right here. But remember, it's not just sine of 4t. We have this unit function. When we have we also have a shift here. So the way I would rewrite this, our final answer, our f of t, right, of our original, right, question mark in the beginning, let me just go ahead and, right, I'm looking for, right, my question mark, right, that is going to be my f of t. So if we go back, well, I'm just going to write this as 5/4. Why 5/4? Well, I have a fourth here, but don't forget about this 5 that I have up here, right? I just didn't work with the 5 because I'm just really multiplying by a constant. But don't forget about that 5. And this is times f of, okay, we're going to shift to the right by 2. We definitely have a unit step function. That's going to shift, right, at 2. And then what's our f of, I mean, we're describing this sum function that's, it's shifting 2 units to the right. Again, another shift 2 units to the right. Well, what's our function? Well, our function is this, it's our parent function, our sine of 4t. But we can maybe say that as sine of 4, and it's not just t. I mean, it has that shift, so I definitely have to include that. And we can rewrite this a little bit nicer. I'm going to write 5/4 sine, let's see, 4t minus 2 times f of t times u of t minus 2. Usually it's standard, right, to write your okay, so your I forgot a minus. That's really a minus 2 there, right? You have your shift, right, of for f. You have your shift of u, and then you have your f of t that you found with your shift. So if we quickly sketch this piecewise function, well, what's it going to look like? Okay, so this guy, and we know that's just 1.25. This is going to be, well, 0, t is going to be less than 2, and I'm just going to go ahead and use 1.25 because we know 5/4 is that. Sine of 4t minus 2, and t is going to be at 2. And some colors here, so that's going to be 0, and that's going to be my blue. So quick sketch, and again, you're more than welcome to use your calculator. So let's see, at from 0 to 2. So okay, so here is 2. So our system is off, right? That's this guy. And now this is just a nice review of trig, right? We know what the sine function looks like. That 4 is just going to be a vertical stretch. Our amplitude is 1.25, and of course our shift. And our period here is going to be a nice little review here of trig. You just take whatever's inside, right, and you equal it to 0, and then you also equal it at 2 pi, because the general period, right, of sine of a sine of x is 0 to 2 pi. And then when you solve for t, right, well, this is where it starts at t equals 2, and then if you solve for t here, you're going to get 2 pi plus 2, which is 6.28 plus 2, which is 8.28. Okay, so that's where it ends. So it's about at 8. So let's just say 1, 2, 3, 4, 5, 6. And okay, it's not perfect, but 7. Let's just say it's 8.28, but it's about 8. So there is 4. Our amplitude is, let's say 1. So let's just say that's 1.25, 1, right, 1.25. So our graph is going to look like the following. So it's not a perfect sine function, right? But it's definitely, right, the lowest point is 1.25, the highest is 1.25. That's not a nice, maybe this is a little bit better, right? So our general sine function, right, but notice it shifts, right? It starts at 2, and again, there's vertical shift, and our period definitely is, well, what is our period? Our period is, well, from 2 to 8, that is, our period is 6. So hopefully that makes sense.